Good morning, everybody. It's 11:01. We're going to give about another minute for people to get in the room. We've got a pretty full room and people are still coming in. My name is Pepper Hastings. I'm with Innovative IDM, coming to you from our Houston office this morning. And our 40-minute, and we promise it won't be any more than 40-minute webinar, will be today, collaborative robots, maximizing efficiency and simplifying safety. And it's possible to do both, is what I'm told by our host today, who is Adrian Choi. And Adrian is the robotics product manager for collaborative robots with Omron. And he is with us this morning from Chicago, Illinois. Adrian, so how's it going up there?
Pretty good. It's finally starting to warm up, but now that I vocalize that, I'm probably going to jinx it. We're probably going to get hit with some snow, knowing our luck.
Well, good. It's great that you took time to be with us today, Adrian, and to share your knowledge for the next 38 minutes or so. And I'm going to go ahead and turn it over to you. As people continue to come into the room, I'll let them in. And anybody who has a question, please type it into the chat box. I'll be happy to forward it to Adrian, or we can do it after the after the 40 minutes are over. Anybody who wants to stay in the room and ask Adrian any questions is welcome to stay as long as you would like. So Adrian Choi of Omron, please take it away.
Thank you very much. And I'd like to thank our host again, Innovative IDM, for this opportunity. So like Pepper said, my name is Adrian Choi. I'm the product manager for collaborative robots here at Omron. Today, we wanted to talk to you about collaborative robots, how to maximize efficiency and simplify safety. Innovative IDM and Omron realized there was a gap between people's assumptions about cobot safety and the realities of it. We wanted to set the record straight and help everyone take full advantage of cobot safety features and learn how you can use this to maximize the productivity of your cobots. Robotics and safety can easily be a week-long course, so we will be going through some very high-level topics. In order to make sure we cover all of the topics, we'll reserve answering any questions to the end of this webinar. So going over our agenda today, we're going to do some introductions on Innovative IDM and Omron. We'll be doing a crash course on cobots. We're assuming that everyone coming into this webinar has some understanding and background on cobots, but we'll do a refresher course. We'll then go into some common misconceptions we've seen in the collaborative robot industry, followed by a list of common and recommended safeguards and safety products used with collaborative robot applications. We'll then go over the risk assessment process and what that entails, and actually apply that on 3 example applications, including desktop screwdriving, CNC machine tending, and palletizing. We'll then give you a buyer's guide on what you should be asking yourself and whoever's selling you a cobot on cobot safety products, what you have to consider before buying your cobot. And then we'll open it up to questions and answers. But like Pepper said, feel free to type in your questions in the chat as we go on. So I'd like to introduce our host today, Innovative IDM. They were founded in April of 2000. They're a distributor of automation and motion control products, offering repair and field service for industrial electronics. Additionally, they offer contract manufacturing and systems integration. They're based out of the Dallas-Fort Worth headquarters, but they have 7 offices throughout the US. As for Omron, we are a full automation product provider, so not only collaborative robots, but we also provide more traditional industrial robots, such as articulated robots, parallel robots, mobile robots. But in addition to that, we offer automation controls, PLCs, safety products. So we truly do have an expansive automation portfolio. Our headquarters is based out of the Hoffman Estates office in Illinois for our US offices at least, but we have 350 offices globally. So let's do a quick crash course on collaborative robots. So collaborative robots is an extremely young field. I think there's some echo going on. If someone can turn off their microphone. Once again, collaborative robots is an extremely young field, just right under 30 years old, which is kind of a baby in terms of technology if you look at industrial automation. Compared to traditional industrial robots, collaborative robots are designed to share workspaces and or interact with humans. So typically, if you were to enter a workspace for a industrial robot, that robot would be required to stop. But with collaborative robots, with all the safeguards and design considerations involved, you can potentially interact with the cobot, share workspaces with it, which can offer some unique features. So common features across the entire collaborative robot industry include fast integration. So there are mechanical and software features included to make sure that cobots can be installed quickly into your operations. Flexibility, so cobots can be repurposed or reconfigured fairly fast for high mix, low volume operations. Programming has been simplified. You'll often see graphic-based programming languages associated with cobots, with options to get into more traditional languages such as ladder logic if necessary. Many cobot companies also have plug and play accessory ecosystems. So they make end of arm tooling and other similar accessories very easy to integrate into a cobot. One of the most pronounced features of collaborative robots is the ability to do speed, power, and force limiting. So if you do have to have a collaborative robot interact with a person or share workspaces with people, you can have it enter a collaborative mode to make it safer to be around and to mitigate risks and injuries. And probably the most important topic of today's webinar is that they are capable of being installed with reduced safeguarding required. We'll put a pin on me emphasizing capable here. I didn't mention this at the beginning, but everything we are presenting here in this presentation is applicable to most collaborative robots on the market and not just our Omron TM cobot. So let's talk about some common misconceptions here. The first one I hear all the time is cobots are inherently safe. You pull it out of the box, you install it at your site, and no matter what you attach to the end of it, it's going to be safe, and that's the end of the story with safety. On the left side here, you can see a recent article from IEEE. Oral sampling robot can save medical staff from grossness. So this is actually a cobot that's been repurposed to give oral and nasal tests. This is an extreme no-go, and this is very common what I see in marketing material and what researchers are looking to use cobots in. I'll tell you why this is not an ideal scenario for a cobot in just a second here. So regarding this misconception, it's a very common assumption we see, but it's obviously not true. Otherwise, why would we be doing a 40-minute webinar on this? An application must be collaborative. You can't look at the robot in a vacuum. Cobots are designed with native safety features such as force and speed limiting and simple things like hardware designs to prevent snagging or pinch points, but the application you use a cobot in itself must also be collaborative. A common metaphor used by our Omron engineers is that you can have a robot that is collaborative, but the moment you attach a butcher's knife or an ice pick to the end of your robot, your cobot is no longer collaborative. So when you consider collaborative application, you have to consider every aspect. You have to consider the cobot itself, the end effector. So are you using a gripper that will reduce the potential of injury if it comes into contact with a person? Payload. Sure, maybe your gripper is safe and your cobot is safe, but if you're carrying a ball of knives, then your application is no longer collaborative. Your shared workspace. Are you creating pinch points? Are you going to entrap workers? And your application itself. If you have a cobot doing welding, is that a collaborative application? Can it be collaborative if you approach it carefully? Regarding what we have in terms of standards with cobots, we do have some standards, but like I said, cobots are a very young technology, relatively speaking. Some of these standards were only initiated in, I believe, 2011. Common ISOs you'll encounter out there is ISO/TS 15066 and ISO 13849-1. These are standards and regulations for specifically cobot systems and their work environments. So these encompass everything from what sort of dwell times you're looking at, stopping distances, how risk assessments need to be conducted for every application. These are very high-level physics analyses of robots, as well as biomechanic injury analyses for humans who come in contact with robots. And like I said, everything, including the body region of collision for a cobot and a person, the duration of that contact event, and everything in between has been calculated and considered. If there are any physics or biomechanics nerds in the audience, the Robotics Industries Association RIA website has some really insightful safety webinars that go over the details and calculations behind these. To comply with these assessments, standards, and regulations, you often need to supplement your cobot with safety products to ensure your application is collaborative. A risk assessment is also required to assess potential causes of injury and to mitigate those risks. Now, you might be asking me then, well, I thought cobots were safe out of the box, and now I have to buy all of these safety products. Why should I buy a cobot if I still need to worry about safeguarding? Which brings us to our next misconception. If safeguarding is still required with cobots, aren't I better off with industrial robots? So here we have a FANUC M2000 IA carrying a Corvette at IMTS in 2016. you'll notice with most industrial robots, the traditional variety, they do boast higher speeds and payloads. So why would you have to deal with a cobot if you can get superior speed and payloads from an industrial robot? Well, there's still several benefits to cobots and cards on the table. You may be better off with an industrial robot depending on your application. Like I said, if you need that higher speed, higher payload of a traditional industrial robot, then maybe that's what you need to consider. But this is all at the cost of not being able to share your workspace at all with an industrial robot. Your application workspace environment will be a strong determining factor in terms of which robot is right for your application and your workspace. Even though you are most likely required to add additional safeguarding with a collaborative robot, it can be significantly reduced compared to a traditional industrial robot. So things like safety barriers, physical fencing, you could eliminate that and free up your footprint for your robotic work cell. The reduced safeguarding can also result in minimizing impact to your existing production environment by reducing the need for physical barriers and other safety products. So if you play your cards right and your application is truly collaborative, you could have a cobot that can fit into your existing operation without disrupting most of your existing equipment and layouts. This is great if you have a limited footprint in your facility or if you have applications where you need to have humans interact with the machine or a cobot or otherwise adjust items in the area. The examples we'll go over in the risk assessment examples will cover some of these scenarios. So there's still benefits to cobots even if you need to supplement them with safety products. A third misconception I see with safety in general and automation. Safe operation is slow operation. We all want our employees to be safe. We want everyone in an automation environment to be safe, but at what cost to production will that impact the ability of time and cost of part per product made versus going any other route? Once again, going down an industrial robot route where you just put up barriers and typically call it a day. Well, with cobots, most cobots on the market can switch between 3 different modes: a collaborative mode with power, speed, and force limiting, an automatic mode where it can run at higher or even full speeds, and full stop modes where you just need it to stop depending on the safeguards involved. So most cobots can trigger these different modes based on safety products integrated into the system. So be they light curtains, scanners, and whatnot. By making sure that you have a risk assessment performed and that your application is truly collaborative, you can actually maximize the time your cobot is spent in higher speed mode such as automatic mode and reduce the time it has to slow down for people around it. So that requires making sure your employees are trained on best practices around the cobot, making sure only trained people are interacting with the cobot, and making sure that you are not only making sure your employees are safe, but you are minimizing how many safeguards you actually need to make sure that your robot can run as fast as possible, as often as possible. So there is value in safety in making sure that you are doing the best to protect your work environment and to make sure that your cobot's running as fast as possible, as often as possible. Regarding safeguarding, here are some commonly used safety products we see with cobots. Obviously, light curtains to gate off an area that can trigger a robot to enter collaborative mode or to do a full stop. 2-hand control switches in case you need to make sure an operator has their hands away from a cobot application. Once again, put a pin in that. We'll be revisiting that topic later. Safety laser scanners are very popular if you need to detect a large area. A lot of our cobot customers are small to medium-sized manufacturers that didn't necessarily lay out their environments with automation in mind. But safety laser scanners can provide a 360 view of detection range for operators coming in and out of a workspace. So this can be a very flexible safety product solution in case you have an environment that wasn't necessarily designed for robots in the first place. There are movable guards and physical barriers. You often see these in scenarios where your existing safety products and sensors have blind spots, and you need to just straight up block out people from entering a workspace unintentionally. They're not always necessary, but once again, stick a pin in that and we'll go over that with our risk assessment examples. There are also safety monitoring relays and safety logic devices. So if you have a relatively simple safety circuit, you can employ safety monitoring relays so that you can trigger different modes, either collaborative mode or full stop mode in your cobot with safety products. Or you can have a safety logic device so you can integrate that into a larger control system and do more complex safety programming. So there's a lot of ways to skin this cat. So like I said before, if you want to comply with ISO standards and regulations, a risk assessment is necessary. So what's all involved with the risk assessment? These are mostly defined by ISO 13849-1. Once again, provides safety requirements guidance on the design principles and integration of safety-related parts of a control system. So our cobots. ANSI ISO 12100, the safety of machinery standard, also covers this. You'll find that most risk assessment services are similar. All of them are based off of standards such as these. So they should follow these general steps. Once again, this could easily be a week-long course, but these are the very high-level topics on what's covered in a risk assessment. Step one is the ball is in your court. You need to share information with your assessment provider on your intended use of your robot and your workspace. What sort of cobot are you using? What sort of end effector are you using? What sort of objects or materials will your cobot be handling? What processes will they be engaged in? Equipping your assessor with all of this information will make the process go more smoothly, and make sure that they're prepared to do the measurements required for this. The next step is task identification. So when the risk assessment is performed and your assessors are on site, they will actually be doing the measurements. They'll be doing the monitoring of your cobot's performance. They'll be measuring out the workspace and looking into details such as your cobot's reaction times, or even the reaction times that your safety circuit has to go through. If your signal has to go through a safety scanner, through a safety PLC, how long does it take to actually have that signal reach the cobot, and how fast can that cobot actually react and stop? You can't beat physics, and you can't just assume that everything's an instantaneous stop. For this entire process, it's focused on protecting people and not the machines. And the process is always done in a group to encourage debate. So you have multiple perspectives and multiple eyeballs looking at a scenario. So after the task identification is done, which also includes identifying the workspaces and who could potentially enter the workspace, then hazard identification begins. What hazards are presented by this application, by this cobot system? Once again, not just the collaborative robot, the end effector, the payload, any other machinery in the area, everything needs to be considered for a collaborative application. So two common examples that we'll be diving into later are crush hazards and entrapment. So can the cobot pin someone between its tooling and a workspace? Can the robot block off access between anyone? Can the robot collide with anyone? During this process, there is actually a scoring system used by risk assessors as defined by ISO standards to identify the risks and grade them in terms of level of severity of injury, what sort of type of hazards are done, the length of exposure of a robot and a person, and the probability of avoiding these risks. Once you have a list of hazard identification identified, you go into the risk reduction step. So having all of these hazards in front of you, what can you do to mitigate all of these risks to acceptable levels? So these can include power, force, and speed limiting, like we said before in collaborative mode. Apologies. Recommending safety products and how to position them to get the most effectiveness out of them, identifying ideal collaborative and shared workspaces based on the risks identified and who could be entering that area. This step will also take into account aspects such as acceptable separation distances based on cobot system reaction times, like I said before. How long does it take for a cobot to actually stop at certain speeds? It could also take into account payloads and grippers. We'll be discussing that when we look at the palletizing application for our example process. So just to reiterate and beat a dead horse, risk assessments are required for every cobot task you have. If you have a cobot doing one task in your facility and you want to reconfigure it later, you have to have a risk assessment performed for that new task as well. So keep that in mind. So we're going to dive into some example risk assessment scenarios here. So before we get into that, I wanted to define some of the workspaces we've been talking about. And there's 3 cases, or actually 5 cases rather here. So the color coding here has 3 different designations. The blue is the robot workspace. So this is a workspace around a robot that is exclusive to the robot. No one can go in and go out. The gray area is an operator workspace. So conversely, that is a space designated only for human operators. The robot cannot extend into that area. So in the first two cases, case one, you have full automation. You have a fixed protective fence. The person can't go into the robot's workspace and vice versa. Or case two, where you have a virtual safety fence, where the person is not allowed to go into the robot workspace and vice versa, but it may not necessarily be a physical barrier. These are common with traditional industrial robots, where contact is not intended and not possible. For case three, this is what we call cooperative scenarios. So there is a scenario where you can engage with the robot, but the robot has to be stopped beforehand. So the shared workspaces are designated by the yellow rectangles. So in both of these cases, case three and case four, you have to make sure that the robot is in a stationary mode or at a stopped mode before you can engage with the robot. So you might need this to do tool changes, you might need this to do cleanings on the robot, but something where due to the application, the end effector, the position of the cobot, you need to make sure it's stopped. Case five is the most unlimited one, where you have a shared workspace where the cobot can be in motion while in the shared workspace with a human operator. Usually in this mode, it enters power and force or speed limited modes, what we've been calling collaborative mode this entire presentation, where contact is possible, but the risk of harm is extremely mitigated. So that being said, let's dive into our first risk assessment case scenario, desktop screwdriving. So in this scenario, an operator holds a part or installs a part onto a jig. Once the part is detected or the operator presses a button, the cobot will pick up a screw from the screw feeder and insert screws into the part. We can then assume that the cobot will not position itself to overhang past this desk, and it will not move in a way where it could potentially come into contact with an operator's head or neck. As defined by those ISO standards, some contact regions with an operator's body are permissible at different speeds. You will have some cobots feature safety setup wizards that will auto-calculate acceptable speeds and forces for different contact regions on the body, but some cobot manufacturers require that to be calculated manually and input yourself. In this scenario, we will assume that the only contact regions would be below the neck. ISO standards state that you cannot have a cobot operation where the cobot is in motion and can come into contact with an operator's head or neck. So here you can see the diagram. Like I said before, the gray area is exclusive to the operator. The blue area is exclusive to the cobot installed on the desk, and this yellow area in between can be shared between both. So what would we need to do in this scenario to ensure that safety is adhered to? So in this scenario, the biggest concern would be the operator's hand becoming crushed between the screwdriving tool and a work surface. To avoid this scenario, you could treat the shared workspace as a cooperative space where the cobot is only in motion after a person is not detected in the space. So you could have the person set up a part on a jig, go to another workstation for a different task, and while that person isn't detected by, let's say, a safety scanner or a light curtain, the cobot can be permitted to move. Alternatively, you can use a device such as a two-hand control switch, like you can see in the bottom left here, to make sure the operator's hands are not near the cobot during operation. So this is probably the easiest scenario we have on our list. Case two, CNC machine tending. So let's say hypothetically, we have a CNC that's placed in the middle of a mom and pop machine shop. The shop wasn't originally designed for automation, but they wanted to automate part loading and operator panel operation via cobot so that their machinists could focus on more important work. The area around the CNC is considered a shared space for cleanup, maintenance, and other tasks. So you would still need operators to go in there to do some minor tasks, but most of the part loading and part removal is done by the cobot itself. So in this scenario, you have a cobot mounted on a mobile push cart. The cobot loads blanks into the CNC and removes finished parts. It can also press buttons on the operator panel for the CNC. In this scenario where you have a CNC in the middle of the room, what do we need to consider? Once again, crushing and entrapment are key features. So you want to make sure that people are away or the cobot is not in motion in such a way where it can entrap people or crush them between the work surfaces and the CNC itself. In this scenario, you could have two laser scanners on either side of the cobot to offer a wide range of detection. So you could have 270 or even 360, depending on your placement of laser scanners, to scan all around the CNC. You could have physical barriers, such as indicated by that yellow and black striped line there. In case your sensors have blind spots that could allow operators to potentially squeeze in and get to an area where they would be pinned by the cobot. You could still have this scenario where the operator can go towards the cobot and towards the CNC machine to do cleanup or to move bins of parts in and out. What you can also do here is if these laser scanners are 2-channel, you can have them detect different ranges. So you can have a wide range that detects people in a large area to make sure the cobot triggers from automatic mode to collaborative mode in case people get too close. You can also have these set to an even smaller range so that the cobot comes to a full stop in case that person gets too close to the machine. So that's how you can mitigate the crushing and entrapment. What you can also do to reduce safeguarding is reposition the CNC up to a wall. You can eliminate those blind spaces merely by pressing it up against a wall. So there's ways you can be clever here to further mitigate the need for safeguarding. Of course, for this scenario too, you could also have a light curtain. Just because I'm suggesting one thing here does not mean that it's the end all be all. The 2-channel laser scanner will also be very important in case this cobot can get into a position where it reaches high enough where it could potentially collide with the person's neck or head region. Moving on to our third and final example application, palletizing. This has been a very hot topic in the collaborative space thanks to the labor shortage. So palletizing often requires the cobot to move at neck or head heights and lift heavy payloads. So for example, with our TM12 robots, they can carry a payload of 12 kilograms. If you allocate 2 or 3 kilograms to the gripper itself, that means you have a nearly 10-kilogram box being lifted at head height constantly by a palletizing cell. At this point, it's not just an issue of cobots colliding with body regions. Obviously, you don't want something as heavy as a 10-kilogram box moving into someone's head or neck at high speed. But consider a scenario where this vacuum gripper on the cobot fails while the robot's moving at high speed. All of a sudden, now you have a 10-kilogram box that becomes a projectile while the robot is in automatic mode. How do you account for that? And in this scenario, of course, you want to make sure that you can have operators come in and out of that shared area so they can unload pallets, load new pallets as necessary. So here's a recommended example. And once again, this is not the end all be all for every application, but this is a hypothetical. You could have a collaborative robot load 2 pallets. So it can focus on 1 pallet at a time. And you can actually program safety products such as light curtains to make sure that they can detect when people are in an area that's being actively loaded and stop the cobot. Conversely, you can have it so that you can program the light curtains so that they don't trip a stop if someone's merely loading in a new pallet or unloading a full pallet. So you can have the cobot alternate side by side and allocate, you can actually change the shared space based on the operation of the cobot. You can also have safety barriers. So in the event that the gripper fails while the cobot's in motion, you don't have to worry about the box flying off. You don't have to worry about people potentially getting into that area, or you can even line it up against a wall, such as you see in the photo to the right, so you can remove some of the necessary needs for that barrier. So once again, this is a very strong scenario to show that it's not just the cobot that you need to be concerned with safety in cobot applications. You have to consider the gripper, the reliability of the gripper, the payload, it being a 10-kilogram box. What happens if that gets dropped on someone at a certain height? So some may challenge this and say, well, if you still have to consider all of this heavy safeguarding for a collaborative robot, would I still not be better off with an industrial robot? But there are still reasons you would want to use a collaborative robot in this scenario. Once again, collaborative robots tend to be simpler to program and reconfigure compared to industrial robots. This means that if you have a high mix, low volume operation or seasonal orders that need to be picked, different levels of pallet geometries you have to account for, you can easily go in and do hand-guided motion programming to adjust for different pallet geometries. So even with all these safeguards in place, you can still have someone go in while the robot is in a safe manual mode. Usually cobots have to be entered into a safer state, a more collaborative state if you're going to do something such as hand-guided programming, and have someone with very little or no programming experience at all configure new pallet geometry. So even with all of this safeguarding, there's still collaborative features you can take advantage of with the cobot. So our last topic today is the buyer's guide, what to ask before buying a cobot. And these are questions you should ask yourself and to ask any of your cobot suppliers. Number one, you should ask yourself, is my application collaborative? Am I picking up hot sheets of glass? Am I trying to take an ice pick to a giant block of ice? Is a cobot the right answer for this? And in some cases, you may come to the realization, no, you're better off with a more traditional industrial robot. And you may benefit from that as well in case you need that boosted speed and boosted payload. It's an honest question you should ask yourself. And that's something you can also ask your cobot supplier as well. We're seeing a lot of cobots being sold in applications where they're not necessarily collaborative applications. Interestingly enough, you can still use a collaborative robot in an industrial case scenario. So let's say a cobot is more cost efficient for you, it's at the right payload, and the full auto speeds are worth it to you, and you don't mind it being in a cage in case it's perfect for your application. You can still use a collaborative robot in a non-collaborative application, but you'll need to introduce safeguards as if it were an industrial robot. The second question you should ask is, what safety functions are available with this cobot? So what sort of safeguards are there? If it breaches the power or force or speed limit, what sort of stops does it engage in? So anyone familiar with safety products are probably familiar with the different stop categories. Does it go into a category 0 stop where all power is removed? How easy is it to restart it from a failure? What sort of safety functions are built into the robot itself without needing ancillary safety products? You should definitely investigate what's native to the cobot before you proceed with that. Number 3, what safety products are compatible with this cobot, and how much safety IO is featured on the cobot? So if you have a cobot with limited safety IO, you may not be able to have enough safety IO to do certain safety product configurations like we saw in our last 3 examples. If you have a scenario that would require 4 safety scanners and you don't have enough IO for that, you might have to introduce a safety PLC to handle that. Additionally, knowing what safety products are compatible with the cobot in advance can be great as a proof of concept to ease your integration. So making sure that validation has been done for product compatibility will make things easier down the road. Number 4, who can actually perform a risk assessment for my application? So you're finding it nowadays that companies such as Omron are capable of providing risk assessments not only for their robots, but also for third-party robots. Can your distributor provide a risk assessment? Are they familiar with the product enough to do this for your specific flavor of cobot? Knowing who can provide risk assessments and if they have enough familiarity with the technology that you are going to employ in your application is important. So that's it for the presentation. I think we can open it up to Q&A.
Yes, sir. Thank you, Adrian. We did have a couple of questions that came in over the chat box. I will say this, I could have probably gone the rest of my life without seeing the picture of the poor man in the dentist chair with the cobot bearing down on him with the drill. I could have, that was a tough way to start things. Here's a question from Tim. It says, if you were deploying cobots to different tasks, how easy is it to set up safeguarding or safety in between tasks? So difficult moving a cobot around.
I'm glad you asked that. We have actually seen examples of cobots with safety scanners mounted directly on the mobile carts like you can see in this scenario. So you can mount safety products onto 2 or 3 or even 4 pillars of this depending on where you have your application set up. So what you can also do with certain cobot programs is you can have your cobot scan a barcode so it knows when to load different programs for different tasks. So you can have a PLC register, hey, I scanned this barcode, I'm at this station for bin picking. So I need to make sure that my safety ranges are set here. I need to make sure I'm looking for certain, or I need to make sure that people are away at X distance before I can move. So you can actually mount safety products like scanners onto the cart, which makes it a little bit easier. Once again, you still need to have risk assessments done for every physical location you're moving your cobot to and every single task you're doing. But you can mount safety products onto the same rig you're pushing around your cobot on. Does that answer your question, Tim?
I think so. I want to mention too, over my right shoulder, you can see a TechMan robot, which has been in a lot of these photos that you've been showing. Innovative IDM has a proof of concept lab in our Dallas office that you can, you don't even have to be in Dallas. If you give us an application, we can shoot some video and try to do some cycle time tests and at least get you to a point to where you might have some additional questions or to ask us later on down the line. And the other thing that we also have is an aluminum extrusion cut shop where we do quite a bit of modular pre-made fencing that you showed in one of your slides as well. And we can build robot safety cells for you using Omron safety products and aluminum extrusion. Another question here this is from Robert. It says, how long does a typical risk assessment usually take? I know it's kind of a loaded question, but maybe a short answer on that.
I hate to give these sorts of answers, but it depends. I think you can definitely reduce the amount of time a risk assessment takes if you engage in that preparation step. Photos, CAD models, anything like specs for end of arm tooling, making sure that you approach a risk assessor that is familiar with that specific model of cobot. Those can all be variables that reduce the time necessary for a risk assessment, but it really depends application to application. But the more details you give them, the better you can make sure that they can go through it smoothly. During a risk assessment, they'll have to do actual measurements, not just measuring the workspace itself, but often measuring contact forces between a cobot and surfaces or even people. So making sure that you supply as much information about your facility and your application as possible can reduce the time. But if you're, let's say, doing one cobot application, that might take anywhere from a full day to a whole week. I don't like giving these answers, but it really depends.
Right. So I wanted to also, one of our engineers is also on this webinar, and he wanted me to be sure to mention he is a TUV functional safety engineer, and Monty Muse out there. Good to hear from you, sir. Wanted me to mention that we can, Innovative IDM can also do risk assessments through Omron or ourselves, either way, depending on, how deep a dive you want to do. One other question I had here came in from, let's see, Justin. It says, this is more broad, what are some ideas where cobots can help with labor shortage?
Yes. So the ways cobots can help with labor shortage. So let's take into an example here. So many tasks that we have seen in, like, let's say logistics. I have seen videos of people manually moving boxes from conveyors onto pallets. And it's a menial task. It's a task that can introduce a lot of injury and bodily stress. And it's something where you don't want to stop your operations just because you don't have a warm body moving boxes off of a conveyor to a pallet. So parts of the benefits of cobots, like I said before, is the fast integration. These are designed to be simple applications. The programming is often conveyed through either visual programming languages that don't require, let's say, a degreed engineer or someone with 30 years experience in automation to handle. The thing I like the most about collaborative robots is that you can use them to replace people, but you can also use them to empower your existing workforce in terms of making sure your robot's no longer a black box. You can have your employees learn how to program these cobots so you can have them focus on more important tasks. So the example with a machinist. If you have a veteran machinist, do you want them loading blanks and unloading finished parts, or would you rather have them focus on more important tasks while a cobot automates this? So in terms of the labor shortage, making sure that you can install a cobot quickly so that you don't have to worry about extended integration times, making sure that you don't have to spend all this money and time redesigning your workspace to introduce automation into your space. This is something that is easy with a cobot, assuming that you are taking into careful consideration risk assessments and proper safety and having all of those ancillary safety products involved. So the short long of it is quicker installation time, ease of use in terms of training your existing staff on how to use it, and ease of programming and reconfiguration if it comes down to that.
Great. That's the questions we had in the queue. I wanted to mention too that this webinar is recorded and will be available on demand for any of you people that have co-workers that might want to see this thing later. I will send you a link to either the YouTube or Vimeo video when I get it posted. Wanted to thank everybody at Omron, especially you, Adrian, for the support for the information here today. Very informative, 41 minutes. Congratulations, sir. You're a man of your word. And we will let everybody go. I don't see any more questions. So everybody is free to go and go to lunch, right?
Sounds like a battle plan. Thank you, everyone.
Okay. Thank you, everyone. See you next time.